Good morning, everyone. Today, my presentation topic is PLA Biodegradable Takeaway Cups. PLA stands for polylactic acid, which is a polymer often introduced as a biodegradable and more sustainable alternative to conventional plastics. However, the main idea of my presentation is that PLA is not simply a plastic that disappears after disposal. Its sustainability depends on the whole system, including material design, consumer sorting, recycling, and industrial composting. So, I will discuss PLA cups from three perspectives: daily life, industry, and ESG. I chose PLA takeaway cups because they are closely related to our everyday life. For example, when we buy bubble tea, coffee, or takeaway food, we often use transparent plastic cups or coated paper cups. Some of these products may be made from PLA or marketed as biodegradable materials. From an industrial perspective, PLA is useful because it can be processed like a thermoplastic. It can be made into cups, straws, films, food containers, and even 3D printing filament. From an ESG perspective, PLA sounds attractive because it is bio-based and compostable. But there is one important question. Why was a material that looks environmentally friendly restricted in Taiwan? This question shows that the issue is not only about the material itself, but also about the waste management system. PLA is a polymer called polylactic acid or polylactide. Its raw material usually comes from plant starch or sugar. These sources are first fermented into lactic acid, and then lactic acid is polymerized into PLA resin. In terms of material classification, PLA is a thermoplastic aliphatic polyester. Because it is thermoplastic, it can be processed by injection molding, extrusion, thermoforming, and 3D printing. This makes PLA suitable for many commercial applications, including cups and tableware. However, PLA also has limitations. Compared with PP or PET, PLA usually has lower heat resistance and lower toughness. This means PLA cups are more suitable for cold drinks, but not always suitable for hot beverages. The key point is that PLA's biodegradability is only a material potential. It does not mean the cup will rapidly disappear in every environment. In daily life, the biggest misunderstanding comes from the word biodegradable. Many consumers may think that if a cup is biodegradable, it will naturally disappear after being thrown away. But this is not necessarily true. PLA cups have many advantages. They are transparent, lightweight, and convenient for cold drinks and takeaway packaging. They also look very similar to ordinary plastic cups, but this similarity creates a problem. Since PLA cups look like PET or PP cups, consumers may put them into the wrong recycling bin. If PLA enters the PET recycling stream, it may reduce the quality of recycled PET. On the other hand, if PLA is not sent to industrial composting facilities, its compostable advantage cannot be fully used. So, in one sentence, the problem is not only the material, but where the cup goes after use. From an industrial viewpoint, companies use PLA because it can fit into existing plastic processing methods. The supply chain starts from crops or sugar sources. These are converted into lactic acid, then into PLA resin pellets. After that, PLA can be processed into sheets, cups, tableware, films, or fibers. For companies, PLA also has business value. It gives a clear green material image and supports ESG communication. However, there are several bottlenecks. PLA is usually more expensive than conventional plastics. Its heat resistance and toughness are limited. More importantly, not every region has enough composting facilities or sorting systems for PLA waste. Therefore, the industrial decision is not simply PLA is always better. It depends on the use condition, contamination level, product lifetime, and available waste treatment route. This slide compares PLA with other common polymers, including PET, PP, and PBAT. PET is commonly used for bottles and clear cups. It is transparent and strong, and its recycling system is relatively mature. PP is often used for food boxes, lids, and straws. It has good heat resistance and low cost, but its recycling value can decrease when it is contaminated by food waste. PLA is bio-based and has a compostable image, but it has limitations in heat resistance and toughness. It also needs source separation and industrial composting to achieve its sustainability benefits. PBAT is flexible and biodegradable, so it is often used in bags and films. However, it is often fossil-based and more costly, and it is commonly blended with PLA. From a material science perspective, structure and properties decide the application, but waste management systems decide the sustainability.
For ESG, we need to consider environmental, social, and governance factors together. For the environmental part, PLA has the advantage of bio-based carbon and composting potential. But if PLA is incinerated or landfilled, these benefits may become much smaller. For the social part, consumers may misunderstand the meaning of biodegradable. Some people may think biodegradable plastics are safe to litter, but that is wrong. This increases the need for public education and better sorting behavior. For the governance part, PLA requires clear labeling, separate collection, composting infrastructure, and suitable policies. Without these systems, the material cannot perform as expected. So, the ESG conclusion is, a compostable material does not mean the system can handle it. Taiwan is a very important case for this topic. Since August 2023, designated businesses in Taiwan have been prohibited from offering biodegradable plastic disposable tableware. The main reason is not that PLA is completely useless. Instead, the policy focuses on reducing single-use tableware and avoiding problems in the recycling system. PLA looks similar to conventional plastics, so it may increase sorting errors. Also, if there are not enough suitable composting or recycling facilities, the environmental benefit of PLA is difficult to realize. This gives us an important lesson in materials engineering. A good material needs more than attractive properties. It must also work in real use conditions and in the waste treatment system. For takeaway cups, if there is no separate collection and industrial composting, PLA may simply turn ordinary plastic waste into harder to sort plastic waste. To conclude, the goal of this presentation is not to say that PLA is completely good or completely bad. In daily life, PLA cups are convenient, transparent, and look environmentally friendly, but consumers cannot easily distinguish them from ordinary plastics. In industry, PLA can be mass-produced using existing plastic processing technologies. However, cost, heat resistance, toughness, and waste treatment are still challenges. From the sustainability perspective, the real solution is not only material substitution, we also need reduction, reuse, source separation, end-of-life treatment, and policy governance. My final message is, PLA's sustainability value is not in its name, but in the match between the material, the use scenario, and the waste system. Thank you for listening.